What is ceramic engineering? It is the science and technology of creating objects from inorganic and non-metallic materials. Examples of ceramics are glass in our windows, vase and pots, mug which we use to drink, and brick. It is done by heating the materials and precipitation reaction, which is dried up. Take a recap of what ceramic materials are. First, it is crystalline. Or partly crystalline structure. Second is it is corrosion resistant, meaning it is rust proof. And hard, also hard. It is hard but brittle. And they are also good insulators. Ceramic engineering, there are two processes in making ceramics. First is traditional. Second is advanced. But let's talk about traditional first. In traditional, there are 7 steps in making ceramics. So first is milling. What is milling? It is a process by which the raw materials are reduced to smaller size. So the raw materials go here, then comes out in finer pieces. So that's it. Next step is batching. In which the oxides which will be added to the materials are being weighed. Then the third is mixing. Mixing the raw materials and the oxide. It is either dry or wet. Sorry about earlier. It was 6 steps, not 7 steps. So let's continue. The fourth step is forming. In which the ceramic or the raw materials are being formed or molded into its final shapes. But not its actual size. You'll know later. Okay. Fifth step is drying. It is in this process the water is removed from the formed material. The heat removes the water and it is carefully controlled. The temperature is carefully controlled not to crack the surface of the dried parts. So the sixth and last step is firing. Firing. The material or the output, the final shape, is passed through a controlled heating process in which the temperature is below the melting point of the ceramic. The oxides are chemically changed to cause sintering and bonding. Sintering is the process in which the ceramic will have a greater strength and fracture toughness. And after that, the product will be stored at the room temperature and ready to go. That's it.
Application of advanced ceramics. Okay. First is the heat engines. The second is the ceramic armor and the electronic packaging. Okay, let's back. First application. Advantages and then the disadvantages of using ceramic materials in heat engines. First is the run at higher temperature. Second is excellent wear and corrosion resistance. And it will be low frictional losses, ability to operate without a cooling system, and then low density. So we are done on the advantages. Next is the disadvantage. Is written too easy to have but weaken the engine. And third is difficult machine. Okay. And then ceramic materials may be possible to be part of the engine blocks, stone coating, and jet engine. Example of the ceramic materials that we can use is the silicone, this, and this. Then the next topic, we're going to do the ceramic armor. These are the material we can use on the armor. This as armor because it is extremely hard to lance. It's hard material, so it can shatter the incoming projectile energy absorbing material underneath. And the next is electronic packaging. Choose to secure holds and provide heat transfer. And then the second one is a good heat transfer coefficient for electrical conductivity. So it's perfect for electronic packaging. They will use the coral nitride, silicone, carbide, and nitride. These three used because they are thermal conductivity, because their thermal conductivity is 10 times for the aluminum, and then they are good expansion match with silicone. That's it. Some 3 applications of advanced ceramics.